Officially day 3 in pre-algebra. It is Thursday, May 29th, and today is like your guys' Friday because we do not have classes on Fridays, which is lovely. Today is a good day to decide, do I need to come in tomorrow during office hours? If you are still feeling unconfident or like you may want some more practice by the end of today, know that I am here on Fridays and you are welcome to come. Absolutely not required by any of you, but know that I will be available and I'm happy to help you. So, for our do now today, I gave you 4 problems and then 5 is the challenge problem with something that I haven't taught you yet, just to see if anybody recognized it. And we're going to start with number 1. We're using variables to evaluate these expressions. We're trying to turn this into just one number, basically. So I have, for number 1, 2x plus 12y. I know x is 5, and y is 3. So how would I start this problem? What could I do first? Yeah, let's go ahead and take our x value, which is 5. And what am I going to do with that 5?
Carry it over to
Yeah. I'm going to replace the x with the value that was given. So instead of 2x, I'm going to write 2 times 5. So I'm going to put parentheses and 5. And that means we're going to multiply them. And what should I do next? Plus. What we got here?
12, 3.
Yes. So we know now that y is 3. So instead of 12y,
12 times 3.
12 times 3. Okay, so I have my variables, my letters, replaced with numbers. So now we need to use our order of operations, our PEMDAS, and decide what do we need to do first from here.
Multiply. 2 times 5.
Yes, 2 times 5, what is that?
10.
10
Plus.
plus
12 times 3.
12 times 3, 36. Good.
Equals 26.
46.
I got that one right.
You got it.
Lord.
Good.
High five.
Good. Okay, so for number 1, we got 46. Good. Go ahead and take a look at number 2. Before we do, though, do we have any questions on number 1? Or we feel good about it? Okay, awesome. So number 2, I have 42 minus x divided by 2y. What should I do here?
The x.
What's my x value?
10.
10.
42 times 10.
Oh, is it 42 times 10?
Oh, wait, I'm sorry. 42.
Yeah, so we have 42 minus x.
Oh, that's a minus.
So,
okay.
yes, 42 minus 10. Yes, divided by 2.
And y is 1.
And y is just 1. So we've got 2 times 1 over there. Okay.
Now we got to come up with subtract 42 from 10.
Now let's make sure that we're doing it all in the right order.
Okay.
Now we have a couple of different operations here. We have 42 minus 10. We have 10 divided by 2. We have 2 times 1. What do we need to do first?
2 times 1 to multiplication.
We need to do our multiplication and our division first. Okay. So, technically, since we have 2y, those were kind of connected. We could do that 2 times 1 first. Or we could do the division first because it's not going to make a difference because if you multiply any number times 1, it's going to stay the same. It won't change it. So what do we want to do first? What are you thinking?
You want to do the division of the 10 divided by 2?
10 divided by 2. What's that give us?
5.
5. And what next?
That's times, you still want to do the multiplication?
Yeah,
And 5
times
times
1, which is
5.
It's still 5, so really I could just cross that 1 off. What else?
And you want to subtract, you want to do 42 divided by, subtracted by 10, which is 32.
Let's see, 42. Now remember, we already got rid of that 10 because we did 10 divided by 2, and it's 5.
5, I'm sorry.
Yeah, that's okay. So 42 minus 5. What's that going to give us? 37.
How did I come up with 32?
32. I think it's because you did 42 minus 10 instead of minus 5. And that is a great example of where sometimes crossing the numbers out when you're done with them can really help prevent that mistake because it's super easy to accidentally use the wrong number if you forget that you're done with it already. So that I will always recommend cross your numbers off when you're finished with them.
Oh, okay.
Yeah. Any questions on number 2? Got that? Let's go ahead. Scooch down to number 3 then. This one's a little bit longer. I've got 3x minus 4 plus 2y.
The x's.
Yeah, we're going to do that 12 and then that minus 5 or that negative 5. So let's start with our x, which is 12. And where does that go?
Well, the 3.
Yes.
Yeah.
We have 3x, which is 3 times x. So we're going to do 3 times 12.
Stop that.
Minus 4 plus
2 times
2 times, yep, my negative 5. That's my y. This one's tricky. I threw a negative in there. Okay, so we have a lot of different things going on. So,
yes, you did.
let's see. I have the 3 times 12 minus 4 plus 2 times negative 5. What should we do first?
3 times 12.
Yes, 3 times 12 is 36.
Minus.
Now let's just rewrite all that. Minus 4 plus
minus
2
negative 10
times negative 5. Yes, and that's going to give us negative 10. So if you were going real slow step by step like I just did, next we're looking and saying, okay, well, we've got addition with subtraction. We still have multiplication here. 2 times negative 5 gives us negative 10. And that's going to end up, let's see what happens there. What's going to happen with this plus sign? It's going to change to that. Now it's minus 10. Because that plus 2, we multiplied it by a negative. So now it's minus 10 instead of plus 10. So let's start breaking everything else down again. We've got 36 minus 4 minus 10. Guys, don't be afraid to speak up and stop me if we need to slow down, if you're still writing something, or if you're not sure where I got something. So, what would I do from here?
You got to subtract, don't you? 36 from 4.
36 minus 4, what is that?
32.
32.
And come on down again.
And we still have minus 10.
But that's a it's 10. Subtract it.
Yes.
Okay, so that's 20 what, 22?
22. Good. Very good. Right. Forgetting it. Four's a little tricky too. I'll wait a second. I see most of us are still writing, so I don't want to jump ahead of you. I'll pause this for a minute and we'll catch up. Now let's look at number 4. I have 25 divided by, in parentheses, x plus 3y. What do I do first?
You times it, don't you?
Before we do any multiplying, what am I going to do with my numbers and letters and variables?
Put them in order?
Yes.
Yeah.
We need to get our expression here with numbers. We can't solve this if we have letters in there. So let's replace the x with 2 plus, I have 3 times y. What's y? 1. Whenever I have a variable that's 1, do I really need to write it in? Why not? It's going to be the same. 3 times y is 1. Now it's going to be 3 times 1. Is that going to change my number at all? No, it's going to stay 3. If it makes you feel better to write the 1 in and then rewrite it again, you can do that.
Oh, okay.
But, yes, it'll just cause you an extra step and make it take longer. So, I'm just going to cross that y off because it was 1. We don't need it. So let's bring down the parentheses. We can't lose that. And then what else do I bring down? 25 divided by. Okay. And now what?
We do the math.
We do the math. What comes first?
3.
3.
3 divided by 25. No. 2 plus 3.
2 plus 3
is 5. So
you
bring down the 5 if you want to.
Yes.
And then you 25 divided by 5.
Yes.
And how much is that? 5. We still got 5, girls.
Yes, we did. Perfect. And that's why it's so important to do what's in parentheses first, because if you would have tried to do 25 divided by 2 first, and then plus 3, you would have got a funky decimal. And that is the right answer.
A funky decimal?
We don't like decimals.
All right, here comes the tricky one.
Yes, this one is trickier. I think it's possible that you can do it, but I haven't specifically shown you how. So let's see.
I tried it.
What did you decide to do when you tried to do this one? What did you do first?
I put my variables where they need to go.
Okay, put the variables where they need to go. So replace the x with 3.
2 times 4.
And then my y.
Oh, okay.
I'm just going to stick them all in at once. My y was 4. And then I'll bring everything down, right? Okay, so we have 2 times 3 minus 1. All of that's in parentheses.
Yep.
Plus 4. And there's a 3 outside of this parentheses.
Yes.
Where'd you go from here?
3.
Okay, 2 times 3. What's that?
6.
6. Brought everything down.
Again.
Then what?
I did 6 minus 1.
6 minus 1, what's that?
5.
5.
Bring it down again.
Oh.
Got it?
Okay, perfect. Perfect. Okay, so now we have 3 times 5 plus 4.
3 times 5 is 15.
Yes.
15 plus 4, 15, 16, 17, 18.
Almost. One
19.
more. 19.
Where?
15,
Plus
16, 17,
Oh,
18,
19, 19. I'm sorry.
19. There we go.
15, 16, 17, 18, 19. You did good.
Yes.
Yay.
Y'all, that is so good. Okay. How do we feel about being able to do these?
I feel pretty good about it.
Feel good? Good. It's tricky stuff,
Yeah,
but you guys are really getting it. That's great. I love it. Okay, I can leave this up for a minute. If anybody is still copying it down, I know this one had quite a few steps. I will wait till we're ready to move on to notes. I'll just pause the recording for a moment. Go ahead and get out whatever you take your notes on. Can I move this?
Yes, you gave me that.
What are you looking for?
My code.
Your passcode?
It's on here. I'll put it on the back here.
And you're already in the classroom, so you should be able to access it. But if you're having trouble, just let me know.
Okay.
I can help.
I want to make sure I have it. All right, you're done.
And if you ever do lose it, I have the classroom code written up on the whiteboard in blue. So I'm going to title this page as Pre-Algebra. It's going to be our day 3 notes. Yes, let me pause this. I'll show you where everything is. All right, so day 3 notes. And today, again, I'm just going to write that the date's 5/9, May 29th. This is page 1. Okay. Now, yesterday, do any of you remember, did I talk to you about like terms? Does that sound familiar at all? No. Okay. I'm going to teach that to you today. So, we are going to title this like, Like, terms, terms, like terms. So, like terms are just numbers that are attached to the same variable, the same letter, and have the same exponent if there is an exponent. And I'm going to write that down for you. So, like terms are numbers attached to the same variable with the same x. Give you some examples. She get that written down first. So when I say numbers attached to the same variable, attached is meaning like when you see something like 3x. 3 is attached to x. 3x is a term. 3x and let's say 2x. These would be considered like terms because they both have x. They have the same variable. So these are like terms. These whenever you have terms with the same variable attached, just like 3x and 2x, you can add them together. So instead of writing it separately, we can just add 3x plus 2x, and that would give us 5x. Good. You guys already know this. Good deal. So what about, for example, I gave you 15m. Any letter can be a variable. 15m minus 12m.
You said they both the same.
Mhm.
They have the same term, so we
Say it.
subtract.
Yes, all we gotta do is subtract. They have the same variable.
Right.
3m.
Yeah, plus 12.
Yes, that would be our answer.
And that's not bad.
That's not bad. That's not bad at all.
I told you I'm your problem child. Okay,
Oh, you're not my problem child. We just gotta work on that confidence, girl. You know
Yes.
more than you think. Now, what about if I tried to do 2x plus 5k?
Now we have a problem.
We have a problem. This is different. These are not the same letter. These are not the same variables. So these are not like terms. If our terms are not like terms, I'm going to write that, not like terms. If they're not the same, we just can't add them together. We can't subtract them. We can't do anything with them. And it just stays like that. Exactly. It would stay like that.
Yeah, I think I remember this a little bit.
Yeah.
Because, and when at the time I wanted to
Right.
add them, and you can't do that.
Exactly. You can't. They're not the same. But what if I did something like this? What if I gave you 5x plus 2y plus 3x.
So you're gonna multiply that 5x.
Five and
5x plus 3.
Yes.
Yep.
Yeah, that's
Yes.
8x.
Because they're alike.
Yep.
Yes.
Right.
Yes.
Yeah.
You guys are so smart. Okay. So if we have something like this, just because there's a y on the 2 doesn't mean that I can't still put the x's together.
Yeah.
This
Okay.
5x and 3x,
That's
these are still like terms. I can combine these. And so what is 5x plus 3x?
8x.
8x. So here's how I would combine all of this. I'm going to write 8x, since we've now combined our like terms. But what do we still have left?
The y.
The 2y.
Plus
So
2y.
we can't get rid of it. We need to add
Plus 2y.
plus 2y.
Yep.
And that's as far as we can go, because these are not like terms. That would be it.
And that would be great.
That's right.
Hold
That's
on.
right.
What did you do?
We looked at 5x and 2y and 3x.
Right, because the 5 and the 3,
Mm-hmm.
you add those together.
Yes.
Yeah,
And that's how we got
You got
8x.
eight,
So
right.
let me write that in. 5x plus
There we go.
3x equals
8x.
8x. So
we
that's
got,
where that came from.
oh, you took the 2 over to.
Yeah,
Yeah.
we still had 2y left, so we had to bring that over as well, just like that. So if we can't combine it with another term, it just stays how it is. We don't get rid of it. It stays, but we just can't change it and combine it. So let's see, let's do another one. How about...
It's almost like a problem undone.
It is. It really is. What about 12x plus 4y minus 3? x plus 2y. Now don't have a heart attack. You can do this. What is going on? What are we gonna do here?
You're gonna have to take that.
The X with the X, the Y with the Y.
Yes, yes. We can't put them all together, but I can put my x's with my x's, and I can put my y's with my y's.
But I mean, the thing is that a minus or subtraction?
Yes, this is where it gets tricky. When you have a bunch of different terms all lined up, we are always going to look at the sign that comes right before the number. So if this was plus 3x, we would add.
Yeah.
Since it's minus 3x, we'll
Yeah,
subtract it.
Yeah.
So let's see, we have 12x minus 3x. So I'm going to do this, and under here I'll write 12x minus 3x,
Yeah.
and that's 9x. And what about my y's?
Now, when I put 4
You add
Y
them.
plus
Mhm, yes.
6.
4y plus 2y gives me 6y. So these are my two terms. What goes in between them? Because I can't just write them next to each other.
What do you mean? What?
We need a sign in between these. A
plus
plus. It's just
sign.
going to be a plus sign. Another way of thinking about the plus sign, I like to think of it as an and sign, because that's really all it is. It's saying I have 9x and 6y. We have 8x and 2y in this other one. Right here in the very first one, we had 3x and 2x, and that made 5x. The plus sign is just an and sign, really. So our final answer is 9x plus 6y. And that's as far as we can go. Now, why can't I go further here? They're different. They're not like terms. Good. Good, good, good. Okay. I want to give you some to try on your own. You think you can do it? Yeah. Let's do it. Okay. Some of us are still laughing. I'll do it on the same page. Right here, I'm gonna write. Please. Give me 3. There's 3 problems to try on your own. And I want you to simplify, that's what we're calling this. I want you to simplify each expression by combining your like terms. I'll pause this and set a little time for you. And we'll look at it together. All right. Number 1. What'd you guys get?
7x plus 10y.
7x plus 10y. Did anyone get something different for number 1?
Yes, I got 1x plus 8y.
1x plus 8y. Ooh, different answers.
Yeah,
How'd you get? Here, let me write down yours. You said you got 7x plus 10y. And then, what did you ladies get?
1x plus 8y.
1x plus 8y. Let's see how we got these different answers. So tell me, how did you get your 7x? Walk me through your process.
Okay, I'll say 4x plus 3x
Okay, so,
equals 4, 5, 6, 7x.
okay,
Then I took it over to the y's and I said, 2y
mm-hmm.
will be 2y minus 6y.
Whenever you wrote your problem on your paper, do you have your original problem? Does it say plus 3x minus 6y?
It says,
It should be minus 3x. Maybe that's where you got that 7x.
okay, it's minus 3x.
Yeah.
I do have that, minus 3x times 3x plus 6y.
Okay, so let's just go through it super
Is that what
slow and
I'm
make
looking
sure
at?
we know what's going on.
Okay.
I'm going to start with my x's. I have 4x,
Mm-hmm.
2y doesn't match, minus 3x is what we see next.
Mm-hmm.
This is where it can get tricky, is we see an x, and I'm like, oh, 4 plus 3, that's 7. I know that. But we have to look at the sign too.
Mm.
So because it is minus 3x, what do we need to do instead?
Subtract.
We need to subtract. So we actually have 4x minus 3x. And what is 4x minus 3x? 1x. Good.
Now I see it.
There we go. Okay, so now let's look at the y's. We have plus 2y
Plus
and plus 6y.
a plus.
So I'm going to write
1 plus 6y.
plus 2y plus 6y. And what's that going to give us?
8.
8y. So our answer is going to be
1x
yes,
plus 8.
plus
Y.
8y. Good. 1x plus 8y. Perfect. So y'all got it. Awesome. 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 All right. How about number 2?
Okay. I got 2y plus 2x.
Me too.
2y plus 2x. Did everybody get that?
Yes.
Okay, let's see. I have 12y minus 10y. Those go together, so that gives us 12 minus 10 is 2y. So that part's right. See the next.
Is 4x.
4x. And then what?
Hold on. 4x minus, no,
Yes.
minus 6. Yeah.
I
Yes.
was saying, I found negative.
Yes. Yes.
It was 2y plus a negative 2. That's what I got.
So we're doing 4x minus 6x.
It is a minus, yes.
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 So let's see here. 4 minus 6. We're gonna get negative 2.
Right.
Because we're starting with only 4 and we're taking away 6. That's more than we started with. Anytime you spend more money than you have, you're going to have a negative amount in your bank account. So when you take away more than you start with, you're going to get a negative number. So just like you said, Ayana, we were having a negative 2x at the end there. So you could write 2y plus negative 2x, but you could also just write 2y minus 2x. Perfect. Perfect. And that's what you got too? Perfect.
2y minus
2y minus 2x.
instead of.
Okay. Number 3. What's going on here?
A lot.
Okay, let's start with the x's. We have 15x to start with.
Mm-hmm.
Minus what?
2.
Minus 2x. And what's that become?
13x.
Yes, 13x.
Now the next one. We have.
I'm gonna say. What was I gonna say? I just did it. It would be negative 20.
Yes.
Plus 4.
Negative 20y plus 4y.
It would be
So-
negative 16.
Yes. Yes. Negative 16y. Perfect. Perfect. Okay. Anybody confused how on earth we got negative 16y? We can talk about it. Wait until you tell me you feel good.
subtracted.
We subtract them. Yes, whenever
Yes.
you add numbers that have different signs like this, you're really subtracting. Different signs, you find the difference. You can also type it in your calculator.
Yes.
So our answer should be 13x minus 16y. Good job, guys. Okay, are we getting it? Is it clicking, making sense? Now, before I assume we all feel amazing about this, I would love for you guys to try to come up with at least one good either question or just something in general that you think makes this difficult. What do you think is going to mess people up whenever they try to do this?
Oh, I know mine. I do the same thing.
I'll give you a minute to think. I need to try to come up with what makes this hard. Why is this difficult sometimes? Why do we get wrong answers on these?
I know with me, sometimes it's the formula, it's the negative and the positive when you slide that in. I notice I get tripped up with that because I'm not paying attention. And then sometimes, a lot of times, it look like either a plus sign or a minus sign because it's not right up there, like at the top. Like it'll put it right up the top at the tip.
So like putting -3 instead of -3?
Like that, yeah.
Okay. So something that I am going to hopefully, I wish we had more time, but in 4 weeks, we're going to do what we can.
Okay.
Something we're going to work on is getting really comfortable with that big minus sign being the same thing as a negative, because in most of the math that you're going to see, at least here and in a school setting, and honestly, I'm going to say in general, in most real life applications, you're more than often going to see that bigger dash. Even though they teach it to you this way, we want to get used to the idea that -3 is the same thing as -3. It's totally the same thing. Because if I have 0 plus -3, the answer is -3. If I have 0 minus 3, the answer is -3. It's going to end up being the exact same thing. But you're actually not the first student that's told me that this totally messes them up. That little sign versus the big one, it's a weird switch to get used to. But I appreciate you pointing that out. So I'm going to try to make sure I'm saying the right words when I teach it so that I'm not making it even more confusing than it needs to be. So let's see. You said you have one.
Yeah, I just want to continue.
Well, right,
I
like
want to continue,
being able to say, okay, I'm done.
Because like she said, it's like an unsolved problem, so it makes you want to solve it, even though there's nothing else to solve.
Right. And this, what we're doing right here, this is more of like drilling and practicing, like knowing what goes together so that whenever we do start solving problems, which I'm going to show you today, you won't accidentally put things together that don't go together. So this won't be the end. We're going to move towards that. And do you have anything that you think might be confusing to other students that might be coming and seeing this?
No.
Or is making sense?
Yeah.
Good. Okay. let's go ahead to the next page. We're gonna make one more page of notes. We've talked about our life terms. Now, I mean, guys, seriously, you guys need to be proud of yourselves because in a normal pre-algebra class, we're on day 3 right now. In a normal 8-week course, we don't get to what I'm about to teach you until like the 3rd week, and you're doing it on the 3rd day, and you're getting it, which is wow, that's pretty impressive.
I think I'm a little slow. I know I'm a little slow. It's been some years.
I think confidence, girl. You're a lot smarter than you give yourself credit for.
I have my brain that's
We all. Okay, so I'm just gonna title this again. This is page 2. Is our day 3 notes continued. Now, the first 2 days, day 1, we focused on making sure that we remember the absolute basics. We went through addition, subtraction, multiplication. We didn't really touch division, but by day 2, yesterday, you guys showed me that you can do division, especially considering we do have the calculators, and it seems that you guys know how to use those pretty well. The next thing that we went to was our variables. We talked about those. We practiced putting them into putting the numbers in for the variables, solving expressions with variables. But now we're going to talk about what do we do when there's a variable and they don't tell us what number it stands for. We're going to find out how to figure that number out ourselves. So we are going to write a word, and I bet you've heard it before. Equation. You ever heard of equation before?
Yeah.
Yeah, I'm sure you have. Equations. You guys know what an equation is?
No.
Any ideas? He's like, Ms. Taylor, just tell us. An equation is basically a bunch of numbers.
I would say letters.
With letters, yes, with letters and with variables with an equal sign.
Okay.
It has to have an equal sign.
Did you think of that line of equation called rows?
Yes, yes. Yes. So equations are, and I don't even need you to write a definition because I'm never going to ask you it. It's just knowing that if I say solve this equation, you know what I'm saying when I say it.
Oh, this problem.
Yes. So we're going to talk about solving an equation. For example, let's say I have, let's say 25 plus x equals, let's say 25 plus x equals 47.
So so we gotta find out what goes for that X that made that 47.
Yes.
So add up from that 25. So 25. Here we go.
I'm going to teach you a trick that's going to make this so easy. It's going to be so easy. So whenever we have an equation, here's the biggest rule with equations, is that equal sign, it's like a balancing beam. This is our balance, and I'm actually going to draw a little picture here. Here's, I'm going to put a little dotted line through my equal sign. This is one side of the equation. This is the other side. Both sides have to be equal, or else that equal sign has no purpose. The equal means this is the same as that. They have to be the same. So I like to think, like I said, of it as like one of those little balances, like in the science room. I don't know if Miss Leslie has one of these, but We need to keep it equal. So if I take something away from one side, I have to do the same thing on the other side. If I add something to one side, I got to add the same thing on the other side, or else they are not in balance anymore. They need to stay balanced. So to solve an equation, we want to see what number can I put for x that makes this true.
Mhm.
We need to get this x by itself so that our goal is to end up with this. I'm going to write goal. Our goal is to get x equals a number, whatever our number is. We're going to move this equation around. We're going to move numbers around and try to get x all by itself over here. So on this side of my equation, I have 25 plus x. What do I need to get rid of to make x be by itself over here?
The 25 plus?
The 25 plus, the plus 25.
Mhm.
I need to get rid of this 25. So here's what we're going to do. If 25 plus a number equals 47, and I want to see what that missing number is, I'm going to get rid of 25. How do I go from positive 25 to 0? How do I get rid of that? Do we have any ideas? We're going to use an operation. It's either going to be adding, subtracting, multiplying, or dividing.
So how do you get rid of it? Say that again.
How do we get rid of a 25? Just the number 25. I want to go from having 25 on this side to having 0 plus x. If I want to get rid of 25, do I need to add 25 more over here? Do I need to? Yes. We're going to subtract 25. So watch this. If I subtract 25 from this side,
Uh-huh.
and I only do it on this side, is my equation still equal?
No.
No. I need to do it on both sides so that it's equal. So I'm going to subtract 25 right here. I'm going to do it over here too. Okay? Minus 25. And guess what? If I start with positive 25 and then I take it away, it's gone.
Yeah.
They just canceled out. That's what we say, they canceled out. Now, what I'm going to do is I'm going to draw a line and I'm going to bring everything down below this line. Now I have x by itself. I'm going to bring down my equal sign. And I can't still have 47 on the other side because I'm taking 25 away from it. So we need to see what is 47 minus 25.
22.
22. Guess what? You just solved for x. You solved your first equation. And we can check to see if we got the right answer. This is like the cheat code, okay? If I want to see, is this the right number? Put it back in. Put it back in. Is 25 plus 22 47?
Yes.
Yes. So you did it. I love it. I think it's so cool that we can do this.
Yeah, that is the easier one to do that.
Right? So much easier than trying to guess.
Yeah.
So let's do another one. That's just our first example. What if I gave you x plus 37 equals 112. Remember, my goal is to get x by itself. So what do I need to get rid of?
37.
37. How do I get rid of 37?
By subtracting.
By subtracting it. Minus 37. And if I do that to this side, where else?
To the other side.
Yes, you have to keep it equal. That equal sign has to be true. Minus 37 on both sides. And then we draw a line. Now, as you're solving equations, I want now, while we're just doing a simple one, to Do your best to get in a good habit of writing it neat. Separate your lines, have it nice and spaced out. Don't rush through it because as we get to more complicated things, you are going to mess yourself up. Do it slow and steady. Make it look nice and neat. Okay? That is going to help you in the long run. So my 37 minus 37, that cancels out. Yes, it's gone. Now what?
Bring your X down.
Bring down my X.
And then you put the equal.
My equal.
And you will subtract the 12.
37.
75.
75. Yes. Yes. X equals 75. You got it. That's so good. How do I check to make sure I got the right number?
You would add that to 37.
I can just put it right back into the original problem. Is 75 plus 37 equal to 112?
Yep.
Yes. We put those together, it makes 112. Perfect. Perfect. Oh, that's so good. Okay. What about, let me give you something trickier. How about x minus 12? Now I'm giving you minus. X minus 12 equals 41. Goal is to get x by itself. So what do we need to get rid of?
It's what, 12.
The 12. How can I get rid of that 12?
I don't know. Subtract
Don't you X it out?
Yeah, well, we can't just X it out. We have to do something to make it
another
X out.
12?
We are going to use another 12, but now we need to decide
Oh.
how. Because on the other problems, I had X plus a number. So to get rid of that, I would subtract it. What do you think we're going to do when I have minus a number?
You're positive?
You're going to add it.
Okay, so
you're going to do the opposite. You're going to add it.
I did that.
Oh.
Yes.
I did.
Okay.
So to get, and here's a good way to think of it. I'm going to draw a quick number line over here. You're trying to get rid of it, and to cancel it out, you need to make it 0.
Mm-hmm.
So if I start at negative 12, how much do I have to add to get to 0?
12.
12. Negative 12 is 12 spaces away from 0. If I add 12, 1, 2, 3, 4, 5, 6, 7.
Well, yeah, because if you put it in the calculator like that, it's going to say 12.
Yes, absolutely. And really, when you have x minus 12, we can ignore everything else. And remember, just kind of pretend this is a negative 12. If I want to get rid of a negative 12, I'm going to add 12, and then it will cancel out to 0. So we're going to add 12 over here.
The answer. Okay.
And what else do I need to do? I got to keep it equal.
You got to do the other side.
Yes, you have to do it to both sides. If you don't, you're not doing anything but messing it up. You have to do it to both sides. My 12's cancel.
Okay.
Okay. Bring down my x. Bring down my equals.
And you just add 41 plus 12.
Yes. 41 plus 12. What is that?
53.
53. Good. That is so good. Give you another one. How about negative 6 plus x equals 15? Very.
So by being a negative, can you still cancel it out?
Yes, you absolutely can.
Okay.
Just like in this one, we had a negative 12, so I added 12. We're trying to get rid of what on this one?
The negative 6.
The negative 6.
So
So
you
how
added.
That's what I forget.
we're gonna add 6. Let's add 6. Now don't let this plus sign confuse you because remember what I told you a minute ago. A plus sign is just a fancy and confusing way of saying and. I have a negative 6 and I have an x. If I get rid of negative 6, I don't need an and sign anymore. I just have x.
Yeah.
It's gone. So if I add 6 over here, it cancels all of that.
It does.
Yes. And then what else do I have to do?
You add 6 to the side.
Yes, do it to both sides. Okay. And then what?
You bring your x down,
Bring my x down.
and you add 15 plus 6.
15 plus 6.
21.
You guys. This is good. Okay. Okay. Now, give you a minute to get that caught up. If you're still writing, take your time. And then I want to have you guys, each of your tables, there should be a pad of sticky notes in the rectangle bins. There should be some sticky notes in each of those. If not, let me know and I can give you some. But I'm going to have you make a note on a sticky note so that we can move it around from page to page and it'll be something that's super helpful. So on my sticky note, I am going to write, let's see. I'm going to write this word, and you might want to watch me write it first before you start copying it because it's kind of big. We want it to fit. Inverse is what it's called. Inverse operations. Inverse operations. Let me zoom in on that for you. We know what operations are, right?
Yes, I can't even think of it. Yes.
I know you know it. It's just the things you do to numbers.
There we go.
Adding, subtracting, multiplying, dividing. Okay, and we want to write that with enough space to draw some things underneath it. So we're going to be talking about those 4 different things. Now, inverse. Is that a word that any of you have heard before or know what it might mean? Might be something that is brand new. So inverse means opposite.
Okay.
Yeah, inverse means opposite. So there's operations, and then there's inverse or opposite operations.
Okay.
When we're solving an equation, notice how we're always doing the opposite.
Mm-hmm.
That's what this is called. We're using inverse operations. So we're going to make a little guide so that as we move on to other equations, we know exactly which operation to use because we're going to have a little cheat sheet here. So the first thing we're going to put, and we're going to make 4 little symbols. Less. Going to go here. And what do you think the opposite of plus is? Negative or minus. So I'm going to do a plus, little arrow to show goes back and forth. The opposite of that is minus. Inversely, the opposite of minus is plus. These are opposites of each other. And I'm going to write and you don't have to write the words. I don't know why I'm even writing it. subtract. Now the next two, I'm gonna write about multiply. What do you think the opposite of multiplying is?
Dividing.
Dividing. Yeah, that's it. So multiply and divide are opposites. And I'm going to show you how that works. So to get addition to cancel out, we subtract. To get subtraction to cancel out, we add. Or negative numbers, we add.
Mm-hmm.
To get multiplication to cancel out, we would divide. To get division to cancel out, we would multiply. We're always doing the opposite. So once you've got that, I'm going to show you some examples with multiplication and division. And there's a light at the end of the tunnel, guys. I'm going to let you out a little early today, but I will give you an exit ticket before you go.
I put on my ticket always. You said always what? Always doing the opposite.
Always doing the opposite.
I
Yes.
put on it too.
Yes. So if that helps too, yes, because you might look back and say, God, what did she say inverse means? Opposites. Opposite. There we go. Okay, so I'm going to move this and I'm going to carry it with me to the next page. And we're going to look at just a few more examples. Make sure that we feel good about it before I make you do it by yourself. Okay. And again, this is day 3, notes continued. Page 3 to me. Pre-Alg here. I think it's a good idea to title your pages. That way when you're flipping back through your notes, you're not just looking at a jumble of numbers. You have some sort of title.
Mm-hmm.
So I'm going to write equations again. I'm going to write equation here. Ooh. No. Man, what is this? Once you got your page started and you've got this problem written down, feel free to just tell me when you're ready. When it started. Okay. What does 5x mean? Times. It's multiplication. That's what's happening here. 5 times x equals 45.
Okay, yeah.
So,
You know.
what do I need to get rid of?
The 5.
The 5. If I am multiplying by 5 here, what's the opposite of multiplying? Dividing.
Right.
So here's how we write it in an equation. You can use the division symbol, but sometimes it'll get a little bit tricky because the division symbol, I'm going to be honest with you guys, you will probably, as we move forward in pre-algebra, algebra 2, geometry, whatever you end up doing, you will hardly ever see this symbol again. Division is almost always written as a fraction, like this. So we're going to divide by 5, like that, on this side. Where else do I have to divide by 5?
Oh, 5 goes in there. 1 time.
Mm-hmm.
Let's stop that. Making a mess. Okay.
Divided by 5 here, what else?
Okay. 1 time, so the 1x equals a 45.
Almost.
Oh, you
Divided by
said-
5 here.
I mean, the
So we
5,
divide
I mean,
by
the 1.
Yes, we have to always do it on both sides. So divide by
really?
5
Okay.
on both sides. So 5 divided by 5 is 1. So technically get
Turn that to a
1x.
fraction?
So it can't, 1x, yeah.
Yeah, we get 1x.
That's what I thought, 1x. But the
Mhm.
only thing I had to do was divide by 5.
Yes.
25, 10, 50, 20,
So it equals
25.
9, right?
Equals, what's 45 divided by 5? 9. And you guys remember earlier, whenever we had 1 times something, we could just get rid of the 1?
Yep.
We can do that here. X equals 9.
Yep.
1x just means x. You don't need it. So really what happened here, when you divided by 5, the 5's cancel.
Yeah.
Yes. And you get x equals 9. And we can check this one too. Let's plug in. Here I have 5, and instead of x, I'm going to write 9. 5 times 9, is that equal to 45?
Yes.
Yes. So it worked. Because 45 is equal to 45. Yes, yes, yes. Good. Okay, let's do another one like that. How about, let me do one with big numbers. See. I'll put something. Okay. 23x equals 1081. Don't let the big numbers scare you. You're doing the same thing. Exact same thing we just did.
23 divided by 23.
Yes, we're going to divide by 23 to get rid of that times 23.
Because that x turned into a division.
So, where else do I divide by 23?
Over the 1,000.
Yes.
1,081.
Uh-huh. Now,
So can you write the division sign there?
you
In the
can.
middle?
You absolutely can. You can do that if you like that better. And I see
Oh, yeah, that'll
students.
help you remember if you always divide.
Yes. If this helps you remember, you can do it. Absolutely. I just want you to know that sometimes if I don't write the division symbol and just do the fraction, it's the same thing as divide. But if that is going to trip you guys up, I can try to make a point to write that division symbol.
But this helps. The note helps. Because
Good.
it tells you
Right?
what
Then
to
you don't
do
have to
when you have-
memorize it.
right with the different signs.
Yes.
So that's what, when I looked over, I remembered, okay,
Yes.
the x means to divide.
Mhm.
Gotcha.
So, what happens to my 23s?
Cancel.
They cancel. They're gone. And now I have x all by itself.
And you would divide that down to 81.
Uh-huh.
So,
What is it?
47.
47.
You good, girl.
Yes.
X equals. Yeah.
47. And this is definitely one I would use your calculator on.
Yes.
I wouldn't be trying to do that in your head.
Because of that down. Wow.
Uh-huh.
No.
No. X equals 47. Good. Now, what about if I gave you, why did I write 1, 5? 2, 3. Okay. How about x over 5 equals 2?
Okay, yes, okay.
So before we look at this and say, what? What's going on? What does this mean? X over 5.
Can you do the same thing?
Not exactly. What did
So
I
what-
tell you that it means whenever you put a line and then the number under it, when you have kind of a fraction?
You divide it, don't you?
This is division.
You
This
divide it.
means x divided by 5. What are we trying to get rid of? The 5. Remember, our goal is to get x by itself. So anything that is not x needs to go. If I have x divided by 5, and I want to get rid of divided by 5, what should I do?
Then you put the times in.
We're going to do the opposite. We're going to multiply now. Since we have division, we're going to multiply to get rid of it. So under here, I can write times 5
Okay.
times 5. Now, you're not really doing 5 times 5. Here is what's happening. These will cancel, and you could just memorize that, but I'm going to give you like a mini 5-minute fraction theory lesson. You don't have to know this technically, but it is good to know. X over 5. This is also like saying 1x over 5. Okay? Now, if I am multiplying by the number 5, I'm going to do this. Put this in parentheses. And I'm taking that times 5 over 1.
Yeah.
Ooh. Okay, so this is what's happening here when I multiply by 5 to cancel it. Just if you're curious. When I multiply fractions, I just go straight across. 1x times 5
Equals 5.
is 5x. 5 times 1 is 5. Those 5's cancel.
Yep.
See that? See that? And that's how we get x by itself. Now, do you have to write that out? No. No. Just know that to get rid of division, we multiply. And so I multiply by 5, and the 5's cancel. So we get x all by itself. We'll bring down the equal sign,
And it'll be 10.
and it would be 10. And we could check our answer. How could I check my answer here?
Put divide 10 by 2.
Okay.
10
No.
divided by 2.
No. Oh, yeah.
That's a
okay,
good
oh, yeah.
idea. Technically, that'll
yeah.
give us 5.
Yeah.
Let's think about this. If I have, let me just rewrite the original problem. I have over here,
We're dividing school, yes?
x over 5, x divided by 5 equals 2. And I just told you that, or we just solved for x. We say x equals 10.
Mm-hmm.
What do we do that we did this morning or earlier?
The x for 10.
Yes, we need to replace the x
Hmm.
with our 10. So here's what I'm going to do. 10 over 5. 10 divided by 5
It's 2.
is 2. Is 10 divided by 5 equal to 2? Double check that.
Yes.
Yes, it is. It is. Look. 10 divided by 5 is 2. Yeah, so 2 equals 2. That's correct. We got the right answer. We did it. Okay,
I do my flow backwards when I was in school.
and that's totally fine. There's so many ways to do
It
this.
really is. It's so crazy.
Right, it really is. Okay, so there's a few examples. I want you to try a couple on your own, see how we're feeling. Okay. Do we still need to see this page or can I move it? Okay, you're good. Everybody good on this? Okay, perfect. Move it. And I'm gonna give you one of each kind to try on your own. So the first one here, all right, try on your own. Let's do plus 12. 1. Four, 4. This one here divided by 3 equals 18. Okay, these 4 on your own. And I'm happy to help if you get stuck. I'm going to pause the recording, set a little timer for us. Okay. All right. So you just did these on your own. And we're just going to run through our answers here. For number 1, how do we solve for x?
Subtract 12.
Subtract 12 from both sides. 12 will cancel.
You bring your x down.
Bring your x down.
And then you subtract 41 to 12.
Yes, and 41 minus 12, what is that?
29.
29. Good. Okay. Number 2, negative 5 plus x is 50. How do I solve?
You would have 5 to 1.
5. Both sides. And 5 will cancel. X comes down. Equals 55. Good, 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 good. Okay, 2 more. 4x equals 24. What does 4x mean again?
Divide 4 times.
Yes, it means 4 times x, and you're correct. We're going to divide. So divide by 4. Divide by 4. And what happens to my 4s?
Cancel.
They cancel. So I have x equals 6. Good, good, good. And last one, number 4. X over 3, what does that mean?
Divide.
Divide. So, yes, we're going to multiply. And I'm just going to stick that in parentheses for fun, I guess. Times 3 times 3. And what happens to my 3s? They cancel. Yes. X comes down. Equals 18 times 3 is 54. Yes. Ladies, you guys are killing it. That is so good. Okay, I'm going to give you your exit ticket. Last assignment of the week. Remember, anything that is due tomorrow is written up there on the board and on Google Classroom. And if you feel like you need a little extra practice or help, I will be here tomorrow. You're welcome to come, but you can also just take a break. Take the weekend. So, let's see. free exit ticket. And same as always, I'm gonna make copies of this exit ticket for anybody that's not here. So if you wanna wait for the copy, you can, but you can also write it on your own if you would rather get it done quicker.
So what do we do?
And
You can always grade it before we.
The do nows, I actually would,
Keep them.
you can keep them,
Okay.
because I saw who was here and who did them, so I can give you guys credit based off of that. Yeah, you can keep them. Okay, so this is due tomorrow, but I would recommend you do it right now, and you can check it before you go, so if you need to make corrections, you know that and don't have to come back tomorrow to see.
Oh, yeah, tomorrow's Friday.
Yes, no class tomorrow. Friday. For this exit ticket, you are going to solve each equation for the value of forget we're using inverse operations. We're doing the opposite of whatever our equation starts with. We got to do the opposite to get rid of it. And I'm going to give you 3 problems today. That's going to be it. Your 3 problems. I'm going to run some copies of this for those of us who are not here, and I'll make enough so that if any of you decide you want to have a copy, or if you just like to have all your exit tickets look the same, you can copy your work over onto this, completely up to you. That is it. If you finish, you're free to go, but don't forget you can also, I can check it for you before you go. So.